All right, very cool. Hey, great to see everyone here. We're so happy to have you and to host you, and we would love to get to know you after the actual interactive session. And like Toby was saying, we want to involve you. We don't want this to be a monologue. We want to have a discussion and dialogue with you together, and also learn about your experiences, about the role of the architect and how it can be lived out in a good way and maybe in not so good ways, and how that also leads to organizational so-called anti-patterns, so unhealthy ways on how to structure an organization. But first things first, my name is Jonathan. I work at Diconium as a director of IT consulting. And I work as a system architect in the Volkswagen project, and would love to get to know you after the little talk. And now Ben can introduce himself.
All right, thank you very much, Jonathan. So my name is Ben. I work as an agile coach, agile master, what we call it here at Diconium. So I work as a SPC, so some of you may know the Scaled Agile framework. So this is actually heavily implemented at CARIAD at Volkswagen, so I help also on the strategic topics of agile transformation, but also the connections to the teams, to the release trains, and how to become more agile. And yeah, so that is actually my topic.
All right, very cool. So with the first thing, we actually want to check in with you. So if you can get out your cell phone and can just scan the QR code, that would be great. Yeah, we will see the answer to the question. We will see them on the screen to your right. So the first question is, where did you live before moving to Berlin? We got Cairo, Düsseldorf, Hamburg, Argentina, Berlin, Brazil, Budapest, Buenos Aires. Wow, cool. Bavaria, Johannesburg, Utrecht. Interesting. I love Berlin. I love how international it is. It's great. Wahlstedt. All right, very cool. All right, so next question. We won't have it on Menti, but you can just raise your hand. So are there any product owners here? Any POs? Yeah, we got 2. All right, great. Okay, how many Scrum Masters or Agile Masters, Agile Expert, Team Coaches, something like that? Got 1, 2, 3. All right, cool. All right, how many consultants? Just a very generic consultant. All right, 1, 2, 3, 4, 5. Okay, very cool. How many developers do we have here? All right, the majority. Awesome. I love it. Okay, any, let's say, managers? Maybe engineering manager. Okay, also a couple.
I guess like half before, because I'm also a developer and a manager.
Okay, so you're like an engineering manager. Okay, great. Okay, any so-called architects here? Don't be shy, don't be shy. Okay. Okay, very cool, very great. Okay, now that we know who's in the room and what the backgrounds are, we want to actually recap on a topic that we had a couple of months ago, because this is the second meetup we're doing on this topic on Tech Leadership 101. Was there anyone here the last time? All right, we got 2. All right, okay, that's okay. But that's why we have this slide on the screen. We want to quickly recap what we talked about, because it connects to today's session. And we had one of our colleagues here, I don't know if he's still here, Lars, but he talked about high-performing teams and how to spot them. And the question was, what actually makes up a high-performing development team? And he asked the question, and for example, in the past, the companies would say, okay, how many lines of code would a team write? And they would measure high-performing based on how many lines of code were actually written. Whether that is a good thing or not, I think we all can say no. Some would say, well, how many stories or how many tickets were actually finished? How many were you able to put to done? Or another measurement was how many story points were actually finished within the development cycle. Well, another measurement could have been how high is the cyclomatic complexity of a program? So how complex does a program get? The higher it is, the worse it gets, or the harder it gets to maintain. Or you could also say, what about the test coverage? Do you have a high test coverage, yes or no? Or if the number of bugs is low. But all those things we can pretty safely say nowadays is that those don't make up a high-performing team. But instead, we came to the conclusion that the DORA metrics, so on the left side we see the tech part within tech leadership, the DORA metrics, the deployment frequency, so how often an organization actually pushes things to production, the lead time for change, how long it takes for a Git commit or commit in general to get to production, the change failure rate, so how many of your deployments cause any kind of impairments in your service, and lastly the mean time to recover, so how long does it take for you to recover from a failure. The research results within Accelerate and the DORA DevOps report show that the companies that are highly successful and that are economically growing, like Amazon, Google, and so on, and but thousands of other companies that were interviewed, show that they really exceed in these DORA metrics, which don't say anything about the business outcome, but just about the technical part. Okay, how often are we actually able to deliver something and adapt to change within the market? And then on the right side, we're talking about the leadership part of leading or building a high-performing team, which is also from a Google team, Amy C. Edmondson, the 5 keys to a successful team. And the first one is about psychological safety. So can a team take risks without feeling or without fearing insecure or embarrassed? So are people allowed to ask stupid questions? Are they able to try out new things, or do they fear punishment by someone? The second one, dependability, is about can we count on each other to deliver high quality on time? So if someone says, I will do this, then you can say, okay, if he says he will do it in that time frame, and it's going to be high quality. The third one is structure and clarity. So are the goals, the roles, and execution plans on the team clear? Does everyone follow them and understand it within the team? Meaning of work is, are we actually working on something that matters to us personally? Can we connect to that? And finally, impact of work simply means, do we fundamentally believe that what we're working on matters within the world? Right? Lastly, we didn't talk about this the last time, but there's a book or an industry best standard called Team Topologies by Matthew Skelton and Manuel Pais. And they basically set up in their research and their work different types of teams. And they basically say about every team that if you want to achieve fast flow in a tech organization, teams should be empowered to build and deliver customer or user value as quickly, safely, and independently as possible without requiring handoffs to other teams or people, like an architect, to perform parts of the work. And basically what we're trying to say here is, okay, we understand that teams are the ones that are doing the work, actually. They're the ones that are providing value. And we want the teams to be autonomous. We want them to work independently. We don't want outside parties to do approvals for the team to actually provide their value within the company. And then the question is, okay, if we want to make sure that the teams are able to do that, why do you actually need someone's so-called architect? Maybe architecture is simply a skill and not a role. Maybe you don't even need an architect because we want the teams to be able to do the work. They should be defining whatever they're going to build because they know the product the best. They have to operate it in production. Why would someone outside of the team tell them how they should be building something, right? But there's a problem with that because when we talk about software and technology, it's never just about the technical parts. Like we were talking about high-performing teams, it's not just the DORA metrics, it's also leadership parts, like psychological safety. And the same thing you can say about software. So there's always teams, there's always people writing software, right? And okay, if you have one service, one app that can be owned by one team, all right, you can say, all right, that's pretty simple, straightforward. You have a vertical integration. That team can own it and ship it to production. That's fine. But what happens if the organization actually needs more than one team to build something, to actually ship end-to-end value to the customer? Maybe you need 2 teams. Maybe you need 3 teams. Maybe you need 10 teams to build a solution that actually brings value to the customer. And that grows in complexity, right? And it's never just about the technology, but it's also about the people behind the technology that is building something. And that's why we're talking about a socio-technical complexity. It's never just about the technical parts. It's also about the organization behind it. How are the teams staffed? What is assigned to the teams? How do the teams communicate with each other? And we'll talk about that a little bit more later on how the software part actually correlates to the organizational part, which Ben will share with us. And with this slide, you can see that we talk about abstractions, right? So with programs, you might have functions. They are packaged together. You have classes, modules, and then they might make up a microservice. And then you have multiple microservices that have to communicate with each other. And so you get systems, and it grows and grows, and it grows in complexity. It grows within the organization. And people might have not full transparency over what all the systems are and who's behind it. And so the question then is, if you have multiple teams and you have multiple systems having to work with each other, how do you take care of these overarching topics? So how do you make sure that the systems can actually talk to each other? How do you ensure architectural safety? Like, for example, if one system goes down, how do you ensure that the whole chain of system doesn't suffer from it, that the whole party isn't ruined because one system decided, I'm not going to give you my service anymore? And here it's just critical that we need to understand we are in a complex world where it's not as simple as one team is owning one thing and they can decide what they want to do, but they actually have to work together with other teams and other systems. So who can take care of these overarching topics? And for that, we often look to the architect. So then the question is, maybe you do need someone, and maybe architecture is not a skill, but actually a role. But what is it now? We talked about the team, we talked about overarching topics. So what do you think the software architect actually is? How would you define a software architect? So we got tech lead within the team. We got a rubber duck. Very nice. Someone to talk to. Yeah?
Yeah, I think it's more of a process,
okay,
more than like a rule for a specific person. So in one of my previous companies, what we do is you start an architectural document proposal, and then you announce it, and you invite other team members from your team or from other teams to comment on it, gather some feedback, and then in a meeting you discuss and challenge. We challenge each other, and at the end we decide, okay, this works for everyone, and this is what we do it.
Okay, very great. You actually talked about having a process in place to introduce architectural changes to the overall system landscape. Yeah, very great. We'll actually have that also later in the presentation. But okay, let's look here. So number 1 is responsible for the overall system design of the product. We got someone who gives technical direction and vision. There's a close race here going on. Rubber duck has 4 choices. Very good. Someone who has the last say on how something gets built, okay? Someone who connects business with tech. As you can see, there's not an easy answer, right? I think that's on purpose too. So anyone else want to share something directly?
Yeah, something that I think is not pretty healthy to delegate all the responsibility to a single person. So I think it's much better to have to take the decisions with the whole team, and the whole team support that architecture. I think it's much better than just trust on a single person.
I think like this question is really about to show us the aspect that the software architect could mean many things. It's a very abstract term, as architecture itself is very abstract. And we ask like, is it a role or a skill? But the role actually implies like what kind of skills do you have? And for me, I identify myself as an architect because I like to design software. But as a software developer, I like to design software as well. So I'm a developer and an architect as well, and an engineering manager. It's a very complex question. This is my take on that.
Mm-hmm. All right, very cool. Yeah, so thanks for those answers. And I totally agree with everything, and I also mostly agree with almost all the answers. But yeah, let's just keep going. We'll get to more unclarity. So you keep using that word. I do not think it means what you think it means. So when we talk about software and computers, actually those have only existed for about 80 years. They haven't been around that long. And you know, we as, let's say within the tech industry, we like to look at other professions to come up with our names, because we don't actually know who we really are. We've only existed for like 80 years, like who are we even? And we're not like medical doctors, we're not mechanical engineers. Are we architects actually? Is that word actually the right word? So where do we fit in? We do call ourselves engineers and architects, but we could only dream of the discipline and the rigor that actual proper mechanical engineers and real architects have out there. The amount of detail they blueprint things with. And if they architect a house and it gets constructed and 2 weeks later it crashes, well, they're on the line. Their whole profession is on the line. If we design a system, a microservice, and we push it to production and it crashes, well, what? Okay, we're gonna fix it quickly. It's a little bit different. So I think we came to the naming because part of us actually wants part of the recognition that comes with these kind of titles, with the professions. But I actually think it's done us some harm, because we'll come to the anti-patterns in a second. But I think calling ourselves engineers and architects actually has us done some harm, because we think that person has the same rigor and discipline as a real architect. So they must have a brilliant mind. They thought out everything. And if they write something down, if they have a context diagram or entity relational model diagram, then it must be correct. And I have to follow it, and I need to implement it this way, and we don't question it. And I think this is one of the anti-patterns we're going to look at in a moment, that a lot of things get documented, and then something gets built, and we think it's a perfect system, but it's actually not. So, but for now, we're stuck with the word architect, and we're going to stick with it, and we're going to try to redefine it within the rest of this little talk. So, looking at this term architect, we kind of found out like about 3 anti-patterns to the role, and those are, for the first one, the centralist. And the centralist is the person that documents pages over pages, diagrams over diagrams. He tries to define the perfect system for the team that then gets implemented. And this person doesn't have a stake in the actual implementation. This person's outside of the team. And this person tells the team, though, what they should be building. And they basically hand it over to the team. The team then has to implement it. They might ask some questions, but they're stuck with it. And the problem with that is that the centralist, he has no idea how complex it is to build something. He has no idea how hard it is to actually operate a system like that. And he also doesn't have a real idea what's actually needed and how to adaptively build something small and then maybe adapt the system over time. And this actually also violates several principles that we know and love from the, for example, extreme programming or the Agile Manifesto. Like for example, you want working software over comprehensive documentation. So whenever you work in an Agile world and you get a huge, in German we say Lastenheft, so a huge requirements sheet, how something exactly needs to be done, well, you're probably in trouble. And whatever you're going to build is probably not going to fulfill customers' needs. Or you also have 𝐒𝐥𝐮, or 𝐒𝐥𝐮. You ain't gonna need it. So defining something ahead of time, the perfect system, without actually knowing what you're gonna need in reality. So the second one is the authoritarian that comes with the title. So we think, okay, an architect, well, he really must know what he's doing. And this gives the authoritarian a lot of pride. And he thinks because he's outside of the team and he has some kind of like an upper role, he's not an engineer anymore, he was one once. He now has the authority to make these top-down decisions, and he's not going to do them solely for the sake of the argument, but solely because of his title and his status. And I think we all know how toxic and damaging that can be in a company. And often with this person, the minute details, so the really small details, are really important to him for some reason. Maybe he even is a technical expert, and maybe he knows what he's talking about. But it's really important to him that it gets built exactly like this, and he's going to do the pull request review. And if it's not done like that, he's going to go back to the developer and really cast him down and say, hey, you got to do it like this. And the last one is the scholar. So the scholar is someone who is actually technically brilliant. He's like a genius, and everyone looks up to him. And everyone thinks like, wow, actually, I would love to be able to design systems like he does. And whatever he does is really great. But he does only see the technology. He forgets about the teams. He forgets about the organization behind it. And he even forgets about the business, that the software he's supposed to design should solve business needs. And often it's just about the elegance on how a system is built, that it doesn't have any redundancies, and it might take a while to implement, but then it's way more robust. But in the meantime, they lost an opportunity within the market. So, question to you, what kind of anti-pattern do you know with the role of a software architect? What's this? I see, maybe it's just a typo. Got the dinosaur, I like that. Someone who doesn't code anymore, but design systems like from 10 years ago. Results focused, authoritarian.
I met like this one archetype, so to say, that he was a theory freak, like knew every patterns, every possible software architecture, but didn't really know how to apply it. So he was really good in theory, but really bad in pragmatic. So that's my anti-pattern.
Love it.
I really like the hype surfer. I really like that one.
The hype surfer, so
Yeah.
the latest JavaScript framework.
Yeah.
We got the quick and dirty, so always going for the quickest solution, not caring about technical debt. Lonely wolf. Yeah, that's a common one. Focus with managerial skills. Team-based rather than hierarchical model. A mix between authoritarian and the scholar. Coordinator. Stalking to best code, algorithm design rather than spotting and avoiding bad practices in the system. Information owner, deaf and indecisive, out loud thinker. Wow, that's harsh. Promote new design patterns instead of evaluating existing documented pattern due to time crunch and efforts to understand it. Overthought complex architecture, silver bullet. Project management without development experience.
Ooh, that's harsh.
Yeah, I think, we can all, you want to share something?
To be honest, I never worked with a role defined like software architect. But I imagine myself working with someone who will make the decision on behalf of me, which is for me the most interesting part for me. How I will design the system, maybe with the team, then we make the decision and then we'll be responsible for that. If someone who will make the decision for me and I'm just kind of slavery just to do what has been designed by someone else, I think it's for me to not be, like, I'll not enjoy the work, that kind of work.
And that connects to the meaning of work, right? That whatever you do, that it matters for yourself. Yeah, very good point. Okay, I think we can move on, but thanks for sharing that. That really resonates with me as well, and I think it's good to see that there's so many people out there that share similar experiences. All right.
Thank you very much, Jonathan. So now come to the next part.
what influence does the architect or architecture even has on organizational structure and organizational design? So there's one man called Melvin Conway. So maybe you heard of the Conway's Law. Who has heard of the Conway's Law here in the room? Some of you, okay. So I'll give you a brief overview what it actually means so everyone can read. But so any organization that designs a system will produce a design whose structure is a copy of the organization's internal communication structure. So what does it actually mean, or what he observed in the 60s was that organizations design whatever they design or build back in the 60s, really rigid code, and that they actually really design it how they communicate in the organizational structure. So if organizations then are regarded as a social system, Conway's Law reflects the idea of systems communication structure. So it can be summarized, if you have a dysfunctional organization, you are designing dysfunctional applications or dysfunctional architecture. And how does it actually affect organizational design? So organizations still are very siloed. I don't know how about you guys, but I work in large enterprises, very siloed. Departments don't talk to each other. And this is actually reflecting in their code and also in their products and services that they develop, that they don't talk to each other, actually inside one company. So when you have processes typically span across function areas, so going to be quite some handovers, what also Jonathan always talked about. So you will have a lot of handovers, which will get you in a lot of trouble. Just giving you a simplified picture. So you have small distributed teams. Every team is actually responsible for the end-to-end service distribution and how they actually distribute or provide their service to other teams. So those teams tend to build software which is modular, more microservice oriented. If you have large collated teams like huge units, departments, they tend to build monolithic architecture, which is like really hard to maintain, difficult to run, and even to scale. So the first anti-pattern in the organizational design is ignoring the Conway's Law. I don't know if you see it in the background, the comic, but so if the Conway's Law is actually true, and most of you maybe know or see it as well, that management drives most of the reorganization and structuring of organization. So that means that management actually designs software architecture. How does it work? So people who have no clue about software architecture or even developing code are responsible for the architecture, but they don't know about it. So how you can actually, work forward? How do you design software architecture in a big organization? So you want to begin to involve tech leaders. So you want to bring in the architects, you want to bring in the product managers who have deep knowledge of the code, but also of the high-level strategic goals, where do you want to go? So, and you want to begin by breaking down silos and constrain the team's ability to collaborate and effectively and build better products. The next anti-pattern is siloed and inflexible architecture. So this is actually the product of ignoring Conway's Law. So siloed organizational structure will actually end up in siloed software architecture, and inflexible organizations will tend to have inflexible software architecture. So Conway's Law in this context serve as a reminder that organizations and software architecture are interconnected. Then central decision making. You maybe know that in the agile way, so you always try to decentralize decision making, give the power to the people, give power to the teams, that they actually can own what they produce, what they build, what they ship. And if you see an organization who tend to be pretty hierarchical and top-down, you have big bosses, management, who makes the decision. So what this actually indicates that this company is really bad at innovating, because you can't innovate if you just bring down top-down knowledge, because you need the knowledge in the team, or the teams have the knowledge how to innovate and how to actually make progress and respond to the change coming maybe from the markets. It also is the inefficient resource allocation, right? So that how can you effectively allocate resources from the top down if you actually have no clue what the teams need? So the next anti-pattern, what I see a lot in big companies, focusing on output over outcome. So output, what also Jonathan already talked about, is feature factory. Maybe some of you know, putting out features is the way to go. How many features did you develop? How many user stories did you bring out and ship? But what is the value behind your features? So what changes when you're developing the features and bring them to the customer? How is the world changing when you deliver features? So also the architects then should focus on the engineers and the outcomes, not the tools and also the technologies. So and also the architects should promote system design that supports built-in quality. So when you only ship features, you maybe neglect the enablers. So the enablers for your infrastructure, the architecture that help the teams discover the problems early and prevent them in the first place. So this results in improved testability and also maintainability of code and other solutions. The next anti-pattern is maturity over capability. So maturity in German, Reifegrad. So a lot of companies measure their success in how mature they are in something. But actually, this is more also a cultural thing. So do you measure success in the maturity, or do you know from your capabilities you want to implement in your company? So do you want to, so let me rephrase that. So maturity actually says that there's something you can actually arrive somewhere. So can you actually arrive somewhere at being good at test automation? Is there a level 1, 2, 3, which actually is the same for every team or a whole division? So focusing on capabilities and where to get better, and going into focusing on the, matureness. I lost it here a little bit. I'm sorry. So capability models focus on more the key outcomes and how the capabilities drive improvement in those outcomes, so that you're actually outcome-based. So this is actually those common anti-patterns I see, or we see. There are a lot more anti-patterns. So let me know, what organizational anti-patterns do you know you see every day in your company, blocking you, hindering you from developing great software?
All right, I think we got some answers. And again, if anyone has something they want to say ad hoc directly, just raise your hands. We got the I know everything, premature team scaling. Ooh, I like that one. Especially startups want to focus on scaling, I think. Avoid failing. Yeah, don't listen to your users. Too much time spent in business discussions, not separating organizational from operational structure. No trust.
Excessive perfectionism.
Excessive perfectionism. Scrum as a silver bullet.
Oh, yeah.
Focusing on CEO's ideas instead of data. We got a hand raised. I'm going to hand it over.
So maybe one anti-pattern I've seen is that you try to pull like a reverse Conway maneuver, so you redesign your organizational structure, but then you don't actually give teams time or new communication paths to actually adopt to that and adopt the architecture. So the code and the architecture changes really slowly, much slower than the organizational structure. So you do like restructure of the organization, hope for the quick fix, nothing happens, and then you do the same thing again and you don't really move anywhere.
Thank you for sharing that. That's really relevant, especially within my context where we're trying to pull a reverse Conway maneuver. So thanks for warning us there. Anyone else? All right, we will see what we have here. Constant change of focus. Yep. Too many meetings, finding the best management tools rather than improving skills. Yeah. Stakeholders known to code. Developers taking a part-time PO role.
See that a lot.
Numbers when well tortured confess anything. Yeah. All right. Very cool. Anyone else want to share something? Okay. So far we've arrived with the ideas that on the one hand we want teams to own their software, to define and build it. On the other hand, we realize we need someone or some process or some way to align between the teams and between the systems in an organization. And we also talked about how do those patterns or those changes, how does software architecture also relate to organizational design or organizational architecture. So the definition of teams, communication flows between the teams. And now we want to come to, let's say, the silver bullet, not, but we want to look at the person of the architect in a different light, in a different meaning. Because we talked about him in a way that he's someone who knows exactly how to specify things and how to design things. And we know that doesn't work. There's so many anti-patterns that are connected to that. So we wanna frame it in a way that we wanna have an evolutionary vision. And this is actually from a book called Building Microservices by Sam Newman. And he talks about that we need to shift our thinking from creating the perfect end product, which is often related with that the architects define a perfect end product, to we actually have no idea what the future looks like. We have no idea what we need. We need to start with what we know now, implement that, learn from it, and then evolve. And so we need to think of it in an evolutionary way. So we need an evolutionary vision and perhaps an evolutionary architect. So we talked about different professions earlier, and I think there is a good example of another profession that we could liken the evolutionary architect to, and that is a town planner or a city planner. In German we say Stadtplaner. And anyone played SimCity before? All right, we got all the old people raise their hands. No, I'm kidding. So in that game, you have to design a city. You have to set up buildings and streets, and you have different zones. And a city planner has to take in a multitude of sources of information. So the city planner has to kind of know what the purpose of the city should be. And the city planner doesn't decide exactly where everything should be built exactly, but the city planner thinks in zones. So for example, he defines or says, okay, this part of the city, it probably makes sense to have an industrial zone. Over here, it probably makes sense to have a residential zone. He doesn't say exactly what the buildings should look like within the zone, but he only defines the zones themselves. And he thinks about, and he deeply thinks about how the flows between the zones should look like. For example, how people get from zone A to zone B, and how those streets or what the different standards should look like, how the lighting should be, where there needs to be maybe a highway, and so on. And so the town planner or the city planner, he realizes that it's futile to know the future, and he just works with what he knows now, and also taking future considerations or future planning into consideration, and tries to work with what he knows now. And I think the comparison with software architecture is obvious. We don't know the future. We have no idea how the market's going to react, and business also wants to be able to react fast. So we can't foresee anything that will happen, really. We don't plan for the eventuality, but we allow for change. So we try to design things that are able to change, that are flexible in nature. And so I think that architects, the role of an architect, has a duty to define somehow a space, because a city is like a space. It's almost like a living creature that evolves. And I think an architect should have the same idea, that he creates or defines something that is able to evolve, that's able to grow, without saying how exactly, in which places, in which way it will grow. But he makes the space habitable for developers, habitable for product managers, that it's able to grow in the purposes it should grow in. So staying with that metaphor, we want to think about zoning, or worry what happens between boxes and be liberal what happens inside. So putting that into perspective with cities, we have the different zones, residential versus industrial. You can think the same way for software systems. So for example, if you've known or applied domain-driven design, you try to think of value streams, customer journeys, and then you try to break it down into business capabilities, and then you break it down into business domains, and then those domains you break down into contexts, and then you basically have these zones defined, and then the key idea is, how do you define the interfaces between the zones? You don't define what is built exactly within that domain, within that capability, but you define, okay, how does this capability talk to this capability? If there's a new requirement or a new, let's say, problem that needs solving, you really try to understand, how does it fit into our existing architecture? Do we need a new zone? Can we attach it to an existing one? And what do we need in order to build it? But the question is, okay, what if you just need to worry about what happens between the boxes? So if you think of a diagram, what tools do you have? What does it actually mean, thinking of worrying about what happens between the boxes? And rules are for the obedience of fools and the guidance of wise men, which is attributed to Douglas Bader, who was a Second World War ace in pilot aviation. And I believe that decisions, so we need to make decisions on what happens between the systems, what happens between the boxes. And decisions are always about trade-offs. So there's no perfect decisions. You can't say this is the right decision forever. You always have to take context into consideration, constraints, what the strategic goals are. And so how do we actually frame our decision making? And that's what we're going to talk about for the next few slides. Okay, so I believe the architect should be connected to the business. So the business side sets the strategic goals of the company on how to make the customers happy. And the architect should be able to understand that. He should understand the business side of things and then have the ability to derive technical guidance or technical guidelines, principles based off of that. For example, if a business decides, okay, our product should be a self-service product, it's not going to be a service to customers, but rather a self-service. So a customer might be a developer instead of an end consumer. well then the architect should know, okay, our customer is going to be a developer. We want to have an excellent developer experience. And that can take on multitude of guidelines for the teams that have to build something within this self-service platform. For example, product documentation. Every developer needs a good, well-written technical documentation on how to apply a service, right? So the product documentation probably shouldn't be in a wiki. It probably shouldn't be, you know, kind of like unclear language. It should be really precise. It should be hopefully like in a static, static website, generate within a static website generator, written in Markdown with many code examples. And the architect should have an idea about that and can derive this kind of guideline. And I think there's many other examples behind that. And so from the business vision, which the architect isn't responsible for, but he should at least require it and ask for it if it doesn't exist. Say, hey, we need a vision here. We need to know where we're going, because if we don't, then we're going to have a hard time to define a system that's going to be able to adapt to the way the company wants to go. But if there is a business vision, then the architect's able to derive a technical vision from it. And from that technical vision, the architect is able to define principles. So principles are meant to help guide the teams to make decisions. Like for example, and principles can also be constraints. Like for example, we have, I don't know if Heroku set up the 12-factor app, or principles for 12-factor app, yeah. I think this is a great example of principles on how to build an app that is able to run well on Heroku. And this will then guide the teams that want to build an app that runs on Heroku to build it well. And it doesn't say how the app should actually be built. It just gives the developers guidance on how it should be behaving. And I think it's really important to keep the list of principles low, because the higher it gets, the more principles you define, the more you get into danger that the principles themselves will contradict each other. They might be hard to understand. They might constrain teams too much. And yeah, you really want to deeply think about what kind of principles you want. One example is, how do you design your APIs? So, for example, you don't want the teams to decide, okay, we're going to do versionless APIs versus another team doing versioned API. I mean, you could do that, but it's probably a better idea to have a standardized way within the whole company that everyone knows, okay, this team is building a versioned API and it's exactly patterned like this, so that they know exactly what to expect from the team. Or you could say that you want a standardized protocol between the services. You probably don't want 10. You don't want protobuf, REST, you don't SOAP, remote method invocation. You don't want all of these at the same time, because it's going to be a mess to communicate with all the different systems at the same time. So that comes to the next point, that you want to define these practices. And the practices are basically the implementation of the principle, or the more technical way of defining a principle. So a principle is more generic, and a practice is actually giving them more guidance, like for example, code style. So if you have 10 teams within a solution, and they all work, let's say, in a front end and a back end stack, you probably want to have a common code style between the teams. Because if you want to switch developers from team to team, which happens often or sometimes, then you want to have the same or similar code style, instead of having something completely different where they have to get into it again. One other example would be if you are more into the operation and managing things, like from a platform side, you probably want to standardize also your operating systems. You don't want to have like 10 different operating systems. You want to narrow it down to 1, 2, or 3. And yeah, I think there's definitely some standards that you always want to take care of, no matter what your business strategy is. Like, for example, monitoring. So with monitoring, you want to make sure that you're able to get a bird's eye view on your whole system landscape health. And that definitely requires some standardization and guidance from the architectural role. And you also want to look at interfaces. We just talked about that. So how do systems communicate with each other? And connected to that, architectural safety. So how do systems actually shield themselves from systems or services that are not behaving correctly? Maybe you want to standardize how circuit breaking is implemented. Are systems allowed to return errors within a 200 OK, or should it always be 4xx and 5xx? And so you want to really deeply think about these things and how you can best enable developers to create new services within your system landscape. And they should be generous, but at the same time, they should also help the teams to build high quality systems. So they shouldn't be too narrow. You still want the teams to be autonomous and innovate and think of new ideas on how to build something, but you still want to give them guidance and make sure that the overall system still has a fast flow. All right, and the question now is for you, what principles come to your mind? So what do you think makes sense to standardize across a whole enterprise or a solution with many teams involved? What do you think makes sense? Maybe you could also share what things work for you right now, where you notice, wow, once we wrote this guideline, it actually helped us a lot and it solved a lot of our needs. Or another question, what shouldn't be a guideline? Where maybe a principle was set and you tried it out and you noticed, actually, this doesn't work. This is making a lot of people upset and this is not actually helping us. How to handle exceptions? Yeah. I think it fits into the point of circuit breaking and how services should behave when something goes wrong. More lower level, reduce complexity. So how to handle technical debt, which we'll talk about in a moment as well. Anyone else want to share directly? Just raise your hand. And introducing new third-party dependencies. Ooh, I think that's a big one. Especially if you work in an environment with legacy applications. I think you want to have the way you integrate things, you want to have standardized, depending on the third party probably. How to do supplier management. How to handle change. Requirements to guarantee data discoverability and quality. Oh, I think that's a big one. That probably comes from our data colleagues somewhere. So quality of data, how we make our services trackable, how they serve our service level objectives, database evolution, develop architecture vision and get agreement with business on that. Yep. Replace legacy systems. So I would say that one falls into also handling technical debt somehow. Build the system in a way that it is testable and monitorable. Yeah, you don't want a ghost system in your landscape. Get tracking and monitoring, stay focused. Some deployment cycles within the teams. Or same deployment cycles within the teams. Yeah. Okay, I think these are some really great ones. Anyone else want to share something? Otherwise, we'll move on. Oh, I forgot this doesn't work. Okay, yeah, so we have a couple more things that the evolutionary architect should take care of. And that one, I think, is a big one that we can all feel. Technical debt. So technical debt is something that the teams should take care of, right? The teams should take care of their own technical debt. Maybe they can even have a backlog of technical debt issues they want to be solving. But looking at the town again, the architect should also have some kind of overview of where we introduce technical debt. And did we do it knowingly? Did we introduce it knowingly with trade-offs, or did it happen under pressure and we didn't create awareness over it? So really know how to handle technical debt, creating awareness in the organization that we might be introducing technical debt in order to meet a business need. And the architect should definitely encourage the teams to take care of the technical debt. He should be helping them and saying, and maybe come to a conclusion, okay, at this point probably makes sense. We should really invest into paying off this technical debt, and then really have the spine towards the business side to say, no, we need to focus on this technical debt now. If we don't do it, the system's going to become unmaintainable. The second one is building teams. So we had, in the beginning, we had some examples of how we don't want one person to be the architect to define all these things, right? Because they affect the whole organization. They affect so many people building things. We don't want there to be one person or maybe even 2 or 3 people to define these things in isolation in an ivory tower. We want there to be a team of people that have an active stake, who have skin in the game of actually building these systems to define these guidelines and these practices. We don't want single people to take care of it. So one definite recommendation is that the architect should be a people person. He should be able to collaborate. He should be empathetic. He should talk to the developers. He should really get into it, do pair programming with them, get into the code reviews, do the refinements together with them, really try to understand where they are, what kind of passion they have, where they want to grow in their career, and then kind of help them. And then also create these groups that make the decisions together. You don't want to push decisions down into the teams. You want to make the teams, you want to make these decisions together with the teams. You want to have the buy-in from the teams, because otherwise it's going to be artificial and not healthy within the organization. And the next one was about governance. So building systems also means that you have to take care of legal matters. It needs to be compliant. You need to make sure that the system that's being built, for example, ensures all the compliance requirements, like for example on certain documentation. And the architect should have a good understanding of what that actually means and should take care that that's being fulfilled. It's kind of often very boring stuff, but at the same time mission critical to the business. And finally, we want to have a system architecture that evolves. And making the connect again to Conway's law, the architect should have an understanding of who the teams are, what kind of people we have in the teams, what kind of systems they own, are those systems mission critical, understanding what requirements are coming in, what the roadmap looks like, and then understanding, okay, we need to evolve the system in such a way that we might have to split the service. It's because the cognitive load for the teams is getting too high. We need to split it here, create a new business domain, and then hire a new team or find new people for a new team. And that's called evolving the system architecture, making the right decisions at the right time with the right people, and ensuring that it stays maintainable, that it's able to adapt to change over time. And so we can summarize then at the end what kind of qualities or attributes this person should have. This person should understand the business vision and translate it into a technical vision and be able to communicate it. This person should be empathetic. It should be able to understand people and to really talk to people and not be status or hierarchy driven, and be able to work with teams. And that goes over to the more active attribute is collaboration. So empathy is you actually feel how another person feels if you were in their shoes. And collaboration is then to work together with them to say, okay, I understand this is an issue right now. Okay, how can we fix it? Do we need to fix it right now? Can we do parts of it now and maybe do the rest later? How should it look like within half a year? And so on, and work together with the teams. The next one's adaptability. So actually ensure that the technical vision is able to adapt over time according to the business's needs. Then autonomy, so finding the right balance between the autonomy within the teams to decide how they want to build things over standardization on where you want to make sure that the quality of the overall system works. And the final thing is governance, which we already had before, ensuring that the system fits the technical vision and fulfills the legal needs. And that's it. We're done. I think, yeah, we're done. I think we have one more mentee. We have one more mentee for you guys. Yeah. There's just 2 questions. I don't know what those questions are, I think, but maybe, can you go to the next slide? All right, so yeah. So we're at the end of the meetup. Actually, not quite the end. Now comes the most fun part. We're going to be able to network. And we would love to hear from you, on the one hand, what you think and what your experiences are with this topic of architecture. And then we also definitely want to like to know from you, how did you like the meetup? It's not over yet, but from now on, how did you like it so far? We would love to improve. And yeah, and we can party.
The next question is just an open one. What to improve?
Okay.
Topics for the next time.
Yeah. It's pretty good. Okay, next slide is, what kind of topics would you like to cover next time? Or do you have any other suggestions for improvements? We are agile. We want to improve, adapt over time. Bio break. Yeah, we're a bit over time, actually. DDD, domain-driven design, engineering manager. How to make decisions, how to deal with technical debt. Human-centric leadership, I like that. Different aspects of lateral leadership. How to prepare for the AI revolution. We got another engineering manager, UI UX strategy, architects and Scrum, AI and teams. That's for our data colleagues. You hear? AI and teams, they want to know about that. AI manager. Capability mapping. Servant leadership. It's actually one of our key elements at our Diconium values. We think that's very important. How to introduce real customer experience. Suggestion for improvement, he was used extensively to refer to the architect throughout the presentations. I apologize, it's not about the male gender, it's definitely there's female as well, and yeah. Product architecture, dev and ChatGPT, dealing with uncertainty and advanced analytics, product dev. All right, cool. I think it's been enough time. We can close it now, and is the food here? Okay, the food is here, there's food out there, there's gonna be music, and lots of space to just connect and network. Don't leave, don't go home, let's get to know each other and exchange contacts. Thanks.